Today I am continuing the chapter chemical reaction of the subject science and technology of class 9, and it is taken in the unit number 15. Okay, this is second part. In first part we learned about the valency and radical, but some of them should be learned again, and then only we'll be able to write the chemical reaction. That's why I want to recall something from the previous class. Look at this. Valency and symbol of different elements. These are the elements. Until and unless we remember all these elements, their valency, their symbol, will not be able to write the molecular formula of the compound. And until and unless we will not able to write the molecular formula, we will not be able to write the chemical reaction. That's why you have to remember valency 1, the elements having valency 1, hydrogen, lithium, sodium, potassium, etc. Valency 2, so sulfur, beryllium, magnesium, lead, calcium, etc. Valency 3, nitrogen, aluminum, iron, etc. In the same way, valency 4, carbon, silicon, sulfur, etc. This way, we have to remember all these. And if we remember all these, then we'll be able to write the chemical equation and chemical reaction. Here, some of the symbols are red colored. What it means? They have variable valency. But do you remember what is valency? I want to repeat this also. The combining capacity of an element or radical is called valency of that element or radical. And these elements, you have to remember their valency and symbol. Okay, now let's go to this radical. What is radical? We can say this way: the group of two or more than two atoms of different elements which behaves as a single unit in the chemical reaction is called radical. We can say like this. Look at this is a radical NO3, and this is called nitrate. Nitrate contains one atom of nitrogen. It is combined with 3 atoms of oxygen, and its valency is 1. But valency of nitrogen is 3, oxygen is 2, but nitrate, this is a group of atom which behaves as a single unit in the chemical reaction. Wherever this unit goes, they act as, this atom acts as a single unit, and that's why this is called radical. It has no any free existence. It is found in the combined. It is found in the compound when it is combined with the element or other radical. This is the radical, one example of the radical. Now let's go forward. I want to show you some radical. This is sulfate, sulfite, nitrate, nitrite, carbonate, ammonium, and their formula is SO4, SO3, nitrate, NO3, nitrite, NO2, carbonate, CO3, and ammonium, NS4, and their valency is 2, 2, 1, 1, and carbonate 2 and ammonium 1. Why I am saying very fast? Because it was taught in previous class also. You have to remember this radical, their formula, their valency. Now remember another matter also. Elements are represented by symbol, radicals are represented by formula, but compound is represented by molecular formula certainly. Okay. Now there are other radical also. Let's talk about them also. Radical hydrogen carbonate or bicarbonate, another hydroxide, bisulfate or hydrogen sulfate, phosphate, chlorate, silicate. These radicals have different formula HCO3 for what? Bicarbonate, hydroxide OH, bisulfate HSO4, phosphate PO4, chlorate ClO3, silicate SiO3, and their valency is HCO3 1, hydroxide 1, and bisulfate 1, phosphate 3, and chlorate 1, and silicate 2. Their valency is different. Now, do you remember all this? It was given in previous class also. You must have clear idea about this. Otherwise, we cannot write the chemical reaction. The valency and symbol of elements should be clear to you, and valency and formula of radical must be remembered before writing the chemical reaction. But there are other also which we must remember. First point is when oxygen combines with an element, then this is called oxide. It means iron is if we have iron and oxygen is combined with iron, then we'll say iron oxide. In the same way, what it means, chloride means chlorine is combined, nitride means nitrogen is combined, sulfide, sulfur is combined, bromide, bromine is combined. If hydride, hydrogen is combined. If iodide, iodine is combined. What it means? If magnesium combines with oxygen, then the name of the compound will be magnesium oxide. If chlorine combines with magnesium, then magnesium chloride. If sulfur combines with magnesium, then magnesium sulfide. This way, IDE represents that particular element combined with particular another element. Okay, now maybe you will be confused about this. Look at this. Nitrate is NO3, its valency is 1. But nitrite is NO2, its valency is also 1. Nitrite is actually nitrogen only, its valency is 3. These three seems to be similar, but this is very different to say nitrate, nitrite and nitrite. Now look at this another one, sulfate SO4, sulfite SO3. But sulfide means sulfur is combined, and fortunately their valency is same. But if someone says iron sulfate, then you have to write Fe for iron and SO4 for sulfate. If iron sulfite, then Fe for iron and SO3 for sulfite. But if iron sulfide, then Fe for iron and S for sulfide. There is another also. You may have a little confusion about this also. Look at this. Ammonium is a radical, its valency is 1 and its formula is NH4. But aluminium appears similar, but its symbol is Al, this is an element and its valency is 3. But ammonia is neither the element nor the radical. This is a compound and compound doesn't have valency. Compound doesn't have valency. Remember this also. When hydrogen combines with oxygen, valency of hydrogen is 1, oxygen is 2. When they combine according to their valency. But when they combine to form water, then what happens? The water doesn't have any valency at all. You have to remember this also. Okay, now let's talk about variable valency also. What I told you just before this, some of the elements have different valency. And metals have different valency. Different metals have different valency in different chemical reaction. Look at this. Iron has valency 2 also, 3 also. Copper is valency sometimes 1, sometimes 2. And mercury is valency 1 and 2. And how can we separate them? How can we understand when its valency is 1, when its valency is 2? It is given by this suffix. If ferrous is told, then valency of iron is 2. And if ferric is told, valency of iron is 3. It means ferrous oxide means valency of iron is 2 at that time. And ferric oxide means valency of iron is 3 at that time. In the same way, cuprous chloride at this time valency of copper is 1, but cupric chloride at this time valency is 2. Mercurous oxide valency of mercury will be 1 and mercuric oxide valency of mercury will be 2. After all this, now we are able to write the molecular formula of different compound. I want to give you example. Look at this. When magnesium combines with nitrogen, then Mg for magnesium and N for nitrogen. And this is magnesium, we are writing magnesium nitrite. How to write magnesium nitrite? We have to exchange the valency of magnesium to nitrogen and nitrogen to magnesium. Valency of magnesium is 2, which should be transferred to nitrogen. Valency of nitrogen is 3, it should be transferred to magnesium. And then this is correct molecular formula of magnesium nitrite. In the same way, look at this another, aluminium nitrite. If someone says, write down the molecular formula of aluminium nitrite, then Al for aluminium and N for nitrite. Valency of aluminium is 3, nitrogen is 3, equal valency, no exchange. If they have equal valency, no exchange. Whether it is 3,3 or 2,2 or 1,1, equal valency, no exchange. In the same way, look at this another also. Ammonium sulfate. Ammonium is NH4. Sulfate is SO4. We know this. Valency of ammonium is 1, but valency of sulfate is 2. Now, 1 we don't have to transfer to sulfate because sulfate itself is 1. But valency of sulfate is 2. It should be transferred to ammonium. While giving valency to the radical, we have to keep that radical in bracket this way. And we have to transfer the valency. The reason is very simple. In ammonium sulfate, 1 radical of sulfate combines with 2 radical of ammonium. And this is correct molecular formula of ammonium sulfate. This way, now we are able to write molecular formula of different compounds. Now we are about to write the molecular formula of different compound, and we are going to write the chemical reaction. But before this, I want to show you some compound, name of some compound. Look at this. This is a little different. Methane doesn't say that it contains carbon and hydrogen. In the same way, washing soda doesn't say that it contains sodium and carbonate. If it is so, then how to know? I mean to say, how to understand that washing soda has got this sodium and carbonate? Now, we must remember all these. If the same washing soda is given like this, sodium carbonate, then we'll write Na for sodium and CO3 for carbonate. And the valency of sodium is 1, which we don't have to transfer to carbonate, but valency of carbonate is 2, which we have to transfer to sodium. This way, this is the correct molecular formula of sodium carbonate. But instead of saying sodium carbonate, if washing soda is told, then what to do? We have to remember this. These are common name, not the chemical name. We have to remember this also before writing the chemical reaction. Now one point is left, and after this we'll go through reaction. The point is very simple. Some of the elements exist in the nature in diatomic state. That's why they are represented by molecular formula. Don't think that only the compounds are represented by molecular formula, but some of the elements are also represented by molecular formula. What are they? All the elements? No. Few elements. Whenever, wherever they produce at certain place, then 2 atoms of that element combine with each other to form a molecule. Just for example, whenever, wherever hydrogen produces, then 2 atoms of hydrogen combine to form molecule of hydrogen. In the same way, 2 atoms of oxygen combines with each other to form oxygen molecule. In the same way, nitrogen also, fluorine also, and chlorine also, bromine and iodine. These are few elements which when produces in any place by the chemical reaction, they exist in the form of molecule, not in the form of atom. That's why if you have to write hydrogen somewhere in the chemical reaction, don't write H, because it exists in the form of diatomic state. That's why we have to write S2. But for iron, we have to write just Fe, because this is monoatomic. Iron is monoatomic, we have to write Fe only. And in the same way, aluminium monoatomic, all other elements are monoatomic. But this, which comes in the reaction of class 9 and 10, they exist in the form of diatomic state. That's why these elements should be written in the form of molecule. Okay, what I told you till now, let's revise a little. First, I told you to remember the symbol and valency of element. Second, I told you to remember the formula and valency of radical. And then we'll be able to write the molecular formula. And then I told you about the chloride, bromide, oxide, sulfide, etc. Ide represents certain element combined with another element. At the same time, I told you about some of the confusion also. Nitrate, nitrite, nitrite, etc. And then I told you about this common name of certain compound. We have to remember their molecular formula, because looking at the name of that compound, we cannot understand which element or which radical is present in that compound. That's why we have to remember this. And lastly, what I told you, oxygen, nitrogen, hydrogen, fluorine, chlorine, bromine, iodine, these are the elements which when produces at certain place, then they exist in the form of molecule. That's why we are writing diatomic, these elements as diatomic, S2, Cl2, etc. Okay, now we are able to write chemical reaction. I want to enter into chemical reaction. Basically, there are 4 types of chemical reaction. I want to mention them. One is called combination reaction. What is it? When 2 or more than 2 elements or compound combine to form a single compound, then that chemical reaction is called combination. It can be defined this way. When 2 or more than 2 elements or compounds combine to form a single compound, then the reaction is called combination, and is also called addition, and is also called synthesis somewhere. Well, whether it is told combination or addition or synthesis, the same. I want to show a video clip. Look at this. Very interesting. The hydrogen and chlorine gas is filled in it, and it is stopped by using cork. They are very reactive. They react without the heat, but heat is applied at the bottom, and this heat, because of this heat, they are reacting very violently. And after the reaction, hydrogen and chlorine combines to form white colored solid substance, that is hydrogen chloride, and that appears as the fume. Look at this, the fume of hydrogen chloride. This is very interesting combination reaction. Besides this, there are many combination reaction. I want to write one of the combination reaction here. Look at this. When hydrogen combines with oxygen, then I'll write S2, not only H. The reason is very simple. Hydrogen is diatomic. If I was writing this sulfur, then I'll write just S only. Hydrogen, when combines with oxygen, oxygen also should be written O2, because it is also diatomic. When these two combine with each other, we know that they form what? Water. Now this is formula equation. Till now not balanced. We can say this is unbalanced equation. I'm not writing word equation for this, because you know how to write word equation. Just hydrogen plus oxygen gives water. But this is formula equation, till now not balanced. With the help of previous knowledge, now I'm going to balance it. Here, I suggest you to start from this place. At the end of the reaction, oxygen is only 1. 1 oxygen is present here, and here we have 2 atoms of oxygen. Now how to balance this? If I take 2 here, then oxygen balances in both the sides. And what about hydrogen? 2 2s are 4. If I take here 2, then hydrogen also balances in both the sides. This way, we can balance the equation. How I balance this? Taking certain number in front of certain molecule. I am heating that molecule with certain number, and I try to balance the other. That's why this is called heat and trial method of balancing the equation. This is combination. Now there are other combination reaction also. Look at this. Aluminium combines with nitrogen to form aluminium nitride. In the same way, here I have given many, but the major point is 2 or more than 2 elements combine with each other to form a compound. If product is only 1, but this reactant is 2 or more than 2, then that is called combination reaction. I have taken just 2 only in the side of reactant, but sometimes maybe 3 or 4 also, but the product of combination reaction is always 1. Okay, this is all about combination. Now, let's talk about decomposition. What is this? This is a chemical reaction in which a compound splits up into 2 or more than 2 elements or other compound. Then the reaction is called decomposition. Look at this chemical reaction in which a compound splits up into two or more elements or other compounds, then the reaction is called decomposition reaction. I want to show certain interesting video clip to show this decomposition reaction. This is one of the decomposition reaction. What is taken here? Hydrogen peroxide is taken and manganese dioxide is added in it. And hydrogen peroxide decomposed to form water and oxygen gas. Because of that oxygen gas, it appears something coming out from this conical flasks. Actually, manganese dioxide helps to dissociate hydrogen peroxide into water and oxygen. It can be seen very nicely by this video clip. Now I want to show the same decomposition reaction on the board also. Look at this. This is potassium, and if potassium is combined with chlorate, chlorate is radical, this is potassium chlorate. And we have to exchange the valency. Potassium valency 1, chlorate valency 1, equal valency, no exchange. And when it is heated, or it is heated with manganese dioxide catalyst, then what happens? This potassium chlorate decomposes into potassium chloride. Valency of potassium is 1, chlorine is 1, equal valency, no exchange, and oxygen. This is the method of preparation of oxygen gas in laboratory, and this method is called heating method of preparation of oxygen gas in laboratory. This is formula equation. You can write word equation very easily, that's why I am not wasting time. This is potassium chlorate, this is potassium chloride, and this is oxygen, and their correct molecular formula is written. Now we have to balance. Now, for balancing, it will be better to see from right hand corner, oxygen 2. Here we have 3. That's why what I am doing, I want to hit this odd number with 2. Then what happens? 3 2s are 6. Now I'll try to balance. Heating with this number, I'm trying to balance. That's why this is called heat and trial method. 3 2s are 6 here, and if I take here 3, then 3 2s are 6, oxygen is balanced. In the same way, chlorine we have 1 in right hand side, left hand side 2. That's why if I take here 2, chlorine is balanced. Potassium 2, this is now balanced chemical equation. This way, we have to put number in front of the molecule, not at the bottom side. At the bottom side, if it is diatomic, then 2 comes. And at the bottom side, because of the exchange of valency, certain number may come. But while balancing, we cannot write number at the bottom side. I mean to say in subscript side, we have to put the number in front of the molecule. Just remember this. Now, look at this also. Here we have so many decomposition reaction. In decomposition reaction, a compound dissociate into 2 or more than 2 elements or other compound. In all these, there is only one reactant, but products are 2 or more than 2. But in case of combination, it was just opposite. Reactants were 2 or more than 2, but products was only 1. Yes, decomposition is just the opposite of combination. Now let's talk about displacement reaction. What is displacement? The element or radical, if displaces another element or radical of certain compound, then the reaction is called displacement reaction. That's why we can define this way. When an element or a radical displaces another element or radical from a compound, then the reaction is called displacement reaction. This video clip gives the displacement reaction example. Zinc pieces are when placed in sulfuric acid, then zinc reacts with sulfuric acid to form hydrogen gas. This zinc reacts with sulfuric acid and hydrogen from sulfuric acid is displaced and gas produces. This is displacement reaction. Not only this, look at this another also. A piece of sodium is when placed in water. This reaction seems to be violent reaction, because this piece of sodium reacts with water and it produces hydrogen gas in this reaction. And this is also displacement because hydrogen from water is displaced. Not only this, there are many reactions which are displacement reaction. When metal reacts with acid, look at this is zinc, this copper, they are reacting with acids, sulfuric acid and nitric acid. When metal reacts with acid, then the metal displaces the hydrogen gas contained in that acid and hydrogen gas becomes free, forming the salt also. And if a metal reacts with another salt, then the reactive metal can displace the less reactive metal from that salt. Zinc displaces copper from this copper sulfate, and so zinc sulfate and copper form. This is displacement. Hydrogen, when reacts with lead oxide, lead is separated. This is also displacement reaction. Now let's talk about acid-base reaction. What is it? Acid-base. You are taught about acid and base in class 8. You have to recognize acid and base looking at the name or looking at the formula. What is acid? It can be understood very clearly because sulfuric acid is written. Acid is written over there. Hydrochloric acid is written over there. Nitric acid is written. Beside this, if you have given this formula, HCl is hydrochloric acid, H2SO4, this is sulfuric acid, HNO3, this is nitric acid. This way, you can easily recognize an acid whether it is given in word or it is given in molecular formula. Okay, acid can be recognized easily. But what is base? Do you remember what is base? These are the metals I want to tell you about the base. This is sodium, this is potassium, this is magnesium, this is calcium, this is aluminium. All these are metal, you know this. And if metal is combined with oxygen, then this is metallic oxide. And if metal is combined with hydroxide, this is metallic hydroxide. And if metal is combined with, again, let's say oxygen, metallic oxide. If hydroxide, then metallic hydroxide, I am exchanging valency also. And if metal combines with oxygen, metallic oxide, or valency of oxygen is 2, aluminum is 3. These are either metallic oxide or metallic hydroxide. Metallic oxide and metallic hydroxide are base. Then these are taught in class 8. If you have metallic oxide or you have metallic hydroxide, then you have to recognize that as base because metallic oxide and metallic hydroxide are bases. Now let's come back to acid-base reaction. After the recognition of acid and base, we can say this way, when an acid reacts with base, then they form neutral compound salt and water. Why neutral compound? Because acid destroys the property of base, base destroys the property of acid, and because of this destruction of property of each other, they form neutral compound, and that neutral compound is always salt and water. And the reaction is called acid-base reaction. Now look at this, acid plus base gives what? Salt plus water, none other than salt, none other than water. Now you can see this. This is the video clip. In first video clip, sodium hydroxide, a base, is mixed with hydrogen chloride, I mean to say hydrochloric acid. When they are mixed with each other, then what happens? They react with each other to form sodium chloride and water. And a little amount of that solution is taken in a watch glass, and if it is heated, then water goes out and sodium chloride can be seen. This way, we can prove that when sodium hydroxide reacts with hydrochloric acid, then they destroy the property of each other and they form neutral compounds salt and water, and salt is sodium chloride and water we know H2O. Water can be evaporated and we will get salt, and this way we can prove. This is acid-base reaction. I want to show you some other reaction also. Look at this. Sodium hydroxide, metallic hydroxide, is reacting with acid, acid-base reaction. Ferrous oxide, metallic oxide, reacting with acid, and this is acid-base reaction. Carbonic acid is reacting with metallic hydroxide, and this is acid-base reaction. In all the acid-base reaction, one of the product is water, another product is what? Salt. How salt forms? This metallic part displaces the hydrogen of the acid. Okay, I want to show one example here. Okay, look at this. This is aluminium, and aluminium, if combines with oxygen, aluminium oxide. Aluminium valency 3 should be given to oxygen. Oxygen valency 2 should be given to aluminium. This is aluminium oxide, correct molecular formula. This is metallic oxide, that's why this is a base. And when it reacts with sulfuric acid H2SO4, we have to remember this formula directly. I told you to remember this directly from the table, and table is given. Now, base is reacting with acid. Then what happens? They form salt and water. Now, I'm writing first water, and I'm writing salt here, but how to write salt? It's very simple. The metallic part of the base, here it is aluminium, displaces the hydrogen of the acid and takes its place. It means I have to write here Al, I have to write here AlSO4. Aluminium valency 3, sulfate valency 2. So I have to write here 2, and valency of aluminium should be transferred to sulfate, and for this radical we have to keep the radical into bracket, and valency of aluminium should be transferred like this. This is aluminium sulfate. Yes, correct molecular formula is written. Word equation you can write easily: aluminium oxide, sulfuric acid, aluminium sulfate, water. But how to balance this? Oxygen 1, I'm not counting this oxygen because sulfate is present in both the sides. That's why I'll count sulfate. Oxygen 1, here it is 3. That's why if we take here 3, then oxygen is balanced. What about hydrogen? 3 2s are 6. Here 2. That's why if I take 3 here, it is balanced now. Sulfate is 3. Sulfate is 3. Aluminium 2. Aluminium 2. This is now balanced chemical equation. Okay. Now I think we finished 4 different types of chemical reaction. Let's talk about some other type of chemical reaction. In your book, what is given? Exothermic reaction. Do you know what it is? Actually, a chemical reaction in which heat evolves is called exothermic reaction. A chemical reaction in which heat energy evolves is called exothermic reaction. Now, I want to give you example. Look at this. This is C6H12O6. Do you know what it is? This is glucose. And when it reacts with oxygen, then what happens? Then we'll get water, carbon dioxide, and energy. Look, this reaction takes place in the cells of each and every living organism, whether animal or plant. This is called respiration. Respiration is the oxidation of glucose, which gives water, carbon dioxide, and energy. Since energy is produced, that's why it is exothermic reaction. Now, how to balance? We are concerned with balancing equation. Oxygen 2, here 1, 3, here 2 plus 6, 8. 8 and 3 cannot be balanced. If you have this problem, then you can start with this hydrogen also. Hydrogen 2, here it is 12. If I take here 6, then 6 2s are 12, hydrogen balanced. Now, what about oxygen? 6 plus 2, 8. 6 plus 2, 8. Seems to be balanced, but not balanced. Look at the carbon. Carbon 1, carbon 6. If I take here 6, then what happens? Carbon is balanced. Oxygen we have to check again. 6 2s are 12 plus 6, 18. Here 6, if I take here 6, 6 2s are 12 plus 6 becomes 18. This way, this is balanced chemical equation of the respiration process. Okay, now let's go to another. Endothermic reaction. What is it? This is the reaction. This is the reaction in which heat energy is absorbed. We can say this way. A chemical reaction in which heat energy is absorbed is called endothermic reaction. I want to give this as an example, calcium carbonate. calcium Ca, carbonate CO3, both of them have same valency 2. That's why no need of exchange of valency. When it is heated, I want to write here because this is endothermic and I want to focus on heat. So I'm writing here in the equation. Calcium carbonate is, if heated at high temperature, then it decomposes to form calcium oxide. Valency 2, 2 equal valency no exchange plus carbon dioxide gas. Now, fortunately, this equation is balanced 2 plus 1, 3. And here carbon 1, calcium 1, calcium 1. Not only this metallic carbonate, maybe zinc carbonate, maybe sodium carbonate, aluminum carbonate, calcium carbonate, magnesium carbonate, every metallic carbonate when heated at high temperature, it decomposes to form respective metallic oxide and carbon dioxide. And in this process, heat energy is absorbed. Now lastly, I want to tell you about the information obtained from the chemical equation. Looking at the chemical equation, what information we'll get? Number 1, name and molecular formula of the reactant left hand side and product right hand side. You can easily understand the name and molecular formula of reactant and product. And second, number of molecule of atoms. Number of molecule of atom can be understood by looking at the number in front of that molecule. If 2O2, 2 molecule of oxygen. If 2S2O, 2 molecule of S2O. 3Al2O3 means 3 molecule of aluminium oxide. This way, number of molecules and atoms of the reactant and product can be understood. Third, ratio of mass of molecule of reactant and product when hydrogen reacts with oxygen. Then, 2 molecule of hydrogen reacts with 1 molecule of oxygen to form water. At this time, we are clear that ratio of hydrogen and oxygen is 2:1 by volume. A ratio can also be understood, and if we convert this into their molecular weight, then mass, by mass also the ratio can be understood. Type of chemical reaction. Which type of chemical reaction? Combination, decomposition, displacement. What type of chemical reaction is this can also be understood. Okay, I told you about the chemical reaction, how to write the chemical reaction. This class is finished. Now we'll meet in some another class with some another matter. Thank you.